Okay, so welcome to this video introducing and demonstrating the TV Wall Mapper program, which is a new product being released on the Underscores label, which makes tools for video artists. This product is a bit different from the other tools we have in our Underscores catalog because it's a purely software project. Usually Underscores researches and distributes hardware for video artists, but this is kind of an exception to that, I guess, although we do have another software project coming out shortly also. Both of these applications are based around making video installations. So this TV Wall Mapper is an open source cross-platform application for creating synchronized TV wall installations. So I'm going to talk a little bit about what that is in this video, and then the hardware that you might use to create a synchronized TV wall installation, and then I'll demonstrate the custom software. Let's take a look at the GitHub page, which is where the code for this project lives, and there's also quite detailed instructions on what it is and how it works. So here you can see the repository for the TV Wall Mapper. It's currently private, but it will be public by the time you're watching this video. So I guess what we first want to talk about is what a synchronized TV wall installation is. And this short GIF here is probably the easiest way to explain it. So you've got multiple TVs set up together, a TV wall, and then the output that's displayed on there is different portions, cut up portions of the same video mapped to the different TVs so that it looks like one large canvas that's been projected onto across multiple TVs. This is the effect that we're talking about, and what this software aims to help you create. So there's kind of two parts to setting up an installation like this. There's the hardware side, which is basically how do you cut up a single video signal into all these different parts to send to the different TVs. And the other part is the software side, which is how do you map in software the positions of the TVs relative to each other so that the image is correctly laid out across the TVs. If you're interested in more about the background of how this came about and some of my research into how these TV walls can be achieved, there's this video work in progress too, where I talk more about that. So you can check that out if you want to go into more detail. But this video is focused on this product that we're releasing. The first option for how you might get multiple video outputs from the same source is by using a computer which has multiple HDMI outputs. So even on my laptop, I could probably get maybe 3 outputs at max if I use some adapters to break out my USB-C HDMI or something like this. Or if you have a desktop, you might have multiple HDMIs, or you may be able to add a graphics card like this picture here, which gives you multiple outputs. So this is kind of the simplest way to get multiple outputs, especially if you only need a couple. You can see here on this diagram, there's the computer which is running the software, and then you've got HDMI coming out of each of the different outputs and being plugged into each of the TVs. I've also notated here the format converter, because sometimes the TVs might not take the format that your computer outputs. For example, if your computer outputs display port, you might need to convert it to HDMI because TVs don't usually have DisplayPort. And so that's something to consider in all these cases. This option is good if you already have the hardware that does this, or if you only need to map a couple of TVs. It can get pretty expensive pretty fast if you are buying graphics cards just to get a couple more HDMI outputs. So the next option, and this is the one that I'm going to be demonstrating today, use a generic TV wall controller hardware to take a single HDMI signal and split it into multiples. So what I'm talking about is these off-the-shelf HDMI video wall controllers. So yeah, these I got from AliExpress. The 2x2 one costs around 25 euros. Here's an example of what it looks like. So this is the 3x3 TV wall controller that we ended up using. You can see here it's got input here. You can put HDMI or DVI into it. You can even control it with RS232 to control some of the settings. And then on the other side, it just outputs all the different parts of that signal cut up into like a grid. So that's the 3x3 one, which is slightly more expensive but gives you more outputs. The one that we're using today in the tiny demo wall, which I've prepared, is the 2x2 one. These are pretty cheap, these controllers. From my experience, they're reliable enough to run for 5 days outside in a paddock without any major issues once the cables were really secured in there tightly. And yeah, you can even chain this with the previous suggestion of using multiple HDMI outs to greatly increase the amount of screens you can map to. So for example, in an extreme case, you could take a computer which had 3 HDMI outputs, buy 3 of the 3x3 controllers, and then map 27 separate TVs. And that is to use a single board computer like a Raspberry Pi per TV to display a unique portion of the video, and then send the video over network, in this case NDI, which is a network video protocol, to a switch, which then broadcasts the same video into all of the single board computers. These are each running the TV wall mapper software, and we can tell each one to basically output a different portion of the image. So this is kind of similar to how TV walls that I've seen being done before this are usually set up. So there's a Pi wall, which is the only other open source solution that I've seen to this TV wall mapping problem, although there may be others I don't know of. But this one involves a separate Raspberry Pi per TV, which can be a good option, although like in the case of, say, a 9-wall TV, you're still maybe paying at least $50 per Pi, which racks up the price to being, $300 or $400 for the installation, compared to one of these HDMI controllers, which may cost you less than $100. So yeah, I haven't found a viable single board computer for this method yet. I was thinking that the Orange Pi 03 maybe it's pretty cheap and it has the network port already built in, but unfortunately this wasn't quite powerful enough to run the software, the mapping software, at a resolution that I found acceptable. I'm going to continue to experiment with some other single board computers. They're getting better and better every month and cheaper, so I think there will be a time when this becomes another good option. The advantage of this obviously is that you can reuse this kind of hardware for lots of different things, not just for TV wall controllers. So if that's something that you may have a use case for, that might be a good option. But at this stage now, at least, it's probably the most expensive option that we've seen. Now it's worth mentioning that what we want to do here in software, this is possible in existing apps. So for example, I know that you can do the same thing that we're doing here in Resolume. It has quite a sophisticated projection mapping features that definitely can handle mapping to a TV wall controller if you have that hardware. The reason why I invested in creating this alternative was because one, Resolume is proprietary and quite expensive, so I wanted to provide something that maybe was a bit more accessible and easier to get hold of, as well as I want something to be cross-platform and definitely doesn't run on Linux. So, and for sure wouldn't run on a single board computer like a Raspberry Pi. So this kind of simple single purpose app which I made, kind of the purpose of that is that it's going to be more lightweight than Resolume, and it will run cross-platform. So hopefully you can put it on whatever hardware you have available to make this work. So yeah, I guess I should mention the availability of the code. So it's open source. The code is on GitHub, and it's based on Open Frameworks, which is a C++ creative code library. So you're welcome to download the source code, and down the bottom here there's instructions on how to install from source for different operating systems. If you have done anything with Open Frameworks before, you're probably going to be pretty confident just it's downloading the code and compiling the extensions that it uses. If you're not comfortable compiling from source or learning how to use Open Framework, I am also distributing pre-compiled versions of this app for each of the platforms that we support. So this will be available in underscores.shop, which is where my other hardware and software tools are available, and it will be available for a small donation to get the pre-compiled versions. You should be able to see now the live video feed from my studio. What you're looking at is a small television and a computer monitor side by side, and below the computer monitor there's two of these small rear view monitors. On the displays now you're seeing quadrants of my desktop background. So what's happening is the video HDMI is coming out of my laptop and going into the 2x2 video wall controller, and that's splitting that image of my desktop up into 4 even quadrants, and those are being sent out of separate HDMI channels to each of these different displays. So the TV and the monitor take HDMI directly from the controller, and the two small monitors, I've got HDMI to composite conversion boxes, which are converting the signal there, because those monitors only take composite. So what I'm going to do is show you how, with this hardware setup, to map out the TV wall. The first thing I'm going to do here is set the number of TVs in my installation to 4, because that's what we are that's what we're using today. So if I click this, I can click here to make it 4, and you can see that created 4 new TVs on the map test. So we can drag those out just with the mouse and clicking on it to get them separated. Now the other settings that we want to change is the monitor display. So we're only using one monitor. Remember I mentioned that you can have multiple HDMI outputs. So here if you did have that, you would increase the number of monitors here, and you can change what each of those outputs is going to, whether they're going directly to a TV or whether they're going to a TV wall controller or what have you. But for this, we're going to keep it on 1, which is called monitor 0, and yeah, we're going to change what monitor that is. So this will read the connected displays on your device. In this case, EDP1 is my laptop screen, but we want to output to HDMI 1, which is the HDMI output that's going into the TV wall controller. So I click on that, and then you should see over here that now our TV walls are showing the test pattern here. So the other settings that I want to change is to make the monitor full screen, and you can see on the installation that before there was like a little bit of the application at the top, but when it goes full screen, that's gone. And then the final thing we need to set here is the TV layout. So we're going to tell the program that we're using a 2x2 hardware controller. So here, if I put on 2x2, now the output is split into a quadrant kind of grid, and each of those quadrants is mapping to the different is then being cut up by the hardware controller and mapped to the different TVs. So now we can see we can drag each of these around individually, and that's going to change each of the displays. So yeah, currently, as you can see here, we've got like a test pattern coming through, and this can be configured here by the video source, which is up the top here. So I'm just going to click on this, and you can change it to test map, and this will just map the basically this part of this thing directly onto the TVs, and that will just give you an indication of which TV is which. So I'm going to go back to the test card for now, and we can start by entering in the measurements for this installation. So the first thing that I'm going to do is we want to measure the width of the whole thing. So I'm going to start from the left topmost pixel on the installation, which is up here, and I'm going to measure all the way to the rightmost pixel, which is here. So we don't care about the bezels on the TV, we only care about the pixels. So if I start that here and go all the way down to there, that's 930 millimeters. So I'm going to enter that into my canvas value, which is here in the software, and I'm going to put 930 on both the height and the width. So that's you could measure the height and then add that in, but that will kind of stretch the image that's coming through. Like our incoming video is not going to be necessarily this resolution, and so for this installation I want to kind of just crop the middle of like a square canvas, so that's why I've used the square canvas values. And then once we've got that placed, we can start entering the width and height of each of the TVs in the installation. So you can see down the bottom here, you can click on each of the TVs and you can see the width and height and position that they are, and enter that. So for this first one, I'll do the same thing as before, but this time measuring just that TV. That one comes to 430 across and 270 high. So 430 and 270. And then I'll do the same. I know that that the TV is the same size as the monitor there, so I'm just going to put that same here. So it doesn't have to be exact. The main thing is that the ratios are approximately correct, because that will mean that the stretching is done correctly. And for this one, like you can see here, that the position of this is currently outside of the canvas, so we can't really see it on here. So I'm just going to put the position to 0 and 0, and then you'll see that that one comes onto the map test there. And then for TVs 2 and 3, these are the small ones, so I'll take the measurement. I know they're the same size, but we'll see the width is around 100 millimeters and the height is around 60. So I'll add that in for both of these. 160, and I'll put the positions to 0 so that we can see it. There it is. And this one I'll do the same. and position to 0. I'm gonna want to place like you can kind of just approximate where these are, like based on the installation, and then just fine tune it. That's one way to do it. If you want to know more about different ways to configure these things, this bit up here called help will walk you through all the different kind of controls. So how you can move them around, clicking on it, dragging, holding shift to resize, or right click and drag. I'm not going to do any of the resizing because we put the size information in already. You can see here that the number 2 is kind of directly in the center below that one. So putting that there, and then 3 is just kind of in the same height but to the right of that. So I've approximately placed them, and then already we can see that like this is starting to look on the output kind of like a test pattern, and the test pattern can help you to get things lined up. Like we can see here, like this, there seems to be this line with the colors inside it continues down here, and so we might want to line that up so that they match. And it's the same with this circle, that curve goes through here but then it doesn't quite match, and then you can see here this line here should go with that line, and so on. This line should go with this line. So the test pattern is quite a good way to get things in place. What I would do now is use the keyboard to fine tune it, and you can here, if I push on the keyboard, it jumps quite a lot. This is the grid size here, 100, but we might want to make that much smaller, let's say 5, and then when you push the keyboard it jumps a tiny bit. So that might be useful for getting this online. We can even make it even smaller once we get down to the nitty-gritty. So now we'll move one at a time, and here now when I'm looking at this line across here, I'm just going to tap the keyboard until it looks like that's like perfectly in line, and then I'll do the same thing with some of the other lines. So let's look at this line coming down here and just tapping the keyboard until that comes into place, and then once the line is in the right place, then you can try and get that curve in the right place, and so on. Yeah, this one needs to go over a little bit. I think that's pretty good. And then this one, I think, yeah, it's not perfect. Like you can't get, there's the green there. So let's try and make that green part of the color bar the same as the others. Yeah, that looks pretty good now. We can save that config, so if we come back to the same TV wall, we can always load it up. We don't have to do this again. And now we can put a different video on to show you the effect. So the few different ways you can get video into this program and its output. One way is to use like a capture card, so, or like a video device. So I could put my webcam on, like if I plugged one of these capture cards like this in, or like a HDMI one to my computer, that will also show up here in the video sources. You can also use in OBS, you can use the virtual camera, which is a plugin that then basically takes the OBS feed and pipes it to a virtual video source. But the other way, and this is sometimes the preferable way to send video between programs and between computers, is by using what's called NDI. So NDI is a proprietary video over IP format, and this program is built to work with NDI, both inputs and outputs. So here you can see, instead of outputting through the HDMI monitor, we could output over NDI, and then we could send that video over a network cable like Ethernet to a switcher, and then split that up and go into the TVs, like one of the hardware configurations I mentioned is possible. But in this case, we want to use NDI as an input. And the easiest way to set that up, if you don't already have something that outputs NDI, so both Resolume and Touch Designer, I know can output NDI, so that's one way you could get video into here. But if you don't have any of those already set up, you can just use OBS. I have a separate OBS open here, which is playing this short video on a loop, and combine this with the NDI plugin. I can output that over NDI, so that's been sent, and then on the TV wall mapper, it picks up NDI coming from Pop OS, which is my computer, and then OBS preview is the signal coming from OBS. So if I click on that, now we can see that video is being sent through the TV wall mapper program. And then so in the program itself, you can see the video is being cut up and sent to each of the different quadrants, like that. And those quadrants are then going through the controller, which is cutting it up and sending it to different TVs. And that makes this pretty accurate video wall effect. So yeah, you can see by watching this that it's pretty good. The mapping we did with that test pattern looks good. If you want to get even more accurate, you can put like a video test pattern, say, on here, which just like shows things moving slowly. I know that Resolume has like a animated test pattern, which then just helps you to like get things all lined up. But just for what we did before with the static one, we got this looking pretty good. So yeah, that's really the bulk of this video. I think that's all I have to say about this. So yeah, it's a bit different to the stuff that we've been making on underscores before now, because it's like very specific for one purpose, and it's kind of more aimed at installation work than like video performance work, which I guess like the instruments or the hardware instruments that I've been designing are more for that. But this is something which, yeah, I've been like using and working in my practice, and I wanted to share that with other people as well, and try and show it in an open, and like it feels harder to price. So I think I'm going to have kind of like a sliding scale, like obviously it's free if you want the source, and you can compile from source for free at any time. This will always be available. But for the compiled versions, I'm going to charge a small fee for them, although again, I'll probably have like a sliding scale where, if it's just for personal use, it can be quite cheap, but if you're using it professionally, then maybe you're encouraged to give a bit more. If you want some individual consulting for how to do your installation, you can email me and we can discuss that. I'm available to be commissioned to help on installations that you're working on as well. So talk to me about that if you want to go into something a bit more deeper than what's here. Yeah, that's all there is for that. So thanks for sticking with me, and have a good night.